In this video, we're going to solve the following related rates problem. A water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So first, let's draw a diagram. So here we're working with an inverted circular cone. So that should look something like this. Now we have that the base radius is 2 meters, so I'll draw this. Should be 2 meters, and we have that the height is 4 meters. So let's say this is 4 meters. Great. And now what are the variables we have? So I'm going to let V be the volume of the water because we're pumping water into this cone. So we'll let V equal volume of water in the cone. And then we'll let R be the radius of the surface. So, the circle as we go up and down the cone changes the radius. So we're going to let R be the radius of wherever the surface is. And maybe I should draw that. So let's say we're at this point, then that will be R. And then similarly, we can let H be the height of the water at time t. So let's say that's perhaps this length. Okay, great. So what information are we given? Well, we're given that water is being pumped into the tank at a rate of 2 meters cubed per minute. So that means that dV dt equals 2 meters cubed per minute. And what are we being asked to find? We're being asked to find the rate at which the water level is rising when the water is 3 meters deep. So we're being asked to find the h dt when the water is 3 meters deep. So basically when h equals 3 meters. Okay, so how can we relate the three variables that we have? Well, we can start by writing the equation for the volume of a cone. So V equals 1/3 pi r squared times height. And so here we see that all of our variables are being used. Now, it'd be very useful to express V as a function of just h, because we want to find the h dt. We don't really want to do anything with r. So how can we eliminate the variable r? And perhaps eliminate is a bad term to use. What I mean is, how can we express r in terms of h? So now we're going to use some basic geometry. We see here in this cone, we have the height of the cone is 4, and the radius at the top is 2. So the ratio of the radius to the height is 2 to 4. Okay, so I can express this as a ratio, or I can express this as a fraction, right? I can write r over h equals 2 over 4. Now, how can I solve for r in terms of h? Well, I can just multiply both sides by h. So I get r equals 2h over 4. And I can simplify because 2/4 is just 1/2. So really, r is equal to h over 2. Now using this, I can plug this into r and the equation of the volume. So we get 1/3 pi r squared. So this is h over 2 squared times h. Now what does that simplify to? This is 1/3 pi times h squared over 4 times h. So this is 1/12 pi h cubed. Again, this is the volume. So now we want to differentiate both sides with respect to t. So what I want to do is differentiate both sides with respect to t. So the left-hand side becomes dv dt. And now I can treat the 1/12 pi as a constant because it is a constant. And I take the derivative of h cubed. So I have 1/12 pi times 3h squared dh dt. Now let's simplify what I have on the right hand side. 3/12 is 1/4, so I have pi over 4 times h squared dh dt. Okay, now I see that I have some variables. I have dv dt, h, and dh dt. Now, what is it that I know and what is it that I want to solve? Well, I know that from earlier, dv dt is 2 meters cubed per minute. And I want to find dh dt when h equals 3 meters. So first what I can do is just solve for dh dt, get that by itself on one side. So I can multiply both sides by 4. So I have 4 times dv dt equals pi h squared times dh dt. Now I can divide both sides by pi h squared. So I have 4 over pi times h squared times dv dt equals dh dt. Now I can start plugging in things I know. So I know that I want to compute dh dt when h equals 3. So I can plug in 3 for h. So this becomes 4 over pi times 3 squared. And I know that dv dt is 2. So what does this become? This becomes 8 over 9 pi. And that's equal to dh dt when h equals 3. And so that's our final answer. But what does this mean? What is this telling us? This is telling us that the water level is rising at a rate of 8 over 9 pi meters per minute. And that is our final answer. So again, let's do a quick recap of everything we did. So first we read the problem and we drew a diagram, and then we labeled the variables that we're working with. We then found what information we know, so we know dv dt, and what information we want to find, which is dh dt when h equals 3. We then came up with an equation that relates all of the variables we're interested in. So in this case, it was the volume of the cone. And then we basically differentiated both sides with respect to t and used the information we know to solve for the information we wanted to find, which is dh dt when h equals 3. If this video was helpful, feel free to like and subscribe.